Hello everyone. Today we will talk about some of the types in Rust. So when you read through Rust open source codes projects, you will come across different types. So it's important to Rust is all about understanding these types, and it's heavily typed language. Type system gives you your program the integrity and accuracy, and we can avoid unknown errors through type system, which will while compilation itself Rust will throw those errors if the types are not compatible between two functions or two different parts of the program. So when I was reading through one of the code, I came across one of the type infallible. So infallible is basically a standard library enum, and it's an error type for errors that can never happen. So why do we need types for errors that can never happen? That's a question, but this will be useful when you're writing a function and that has an input of another function, and you want to make sure that user passing function never fails, or at least it should have an infallible type when it returns. So those kind of scenarios you can use this type, and you will see that infallible type in hyper code. So I was reading through Hyperium is one of the low level HTTP library in Rust. So when you read through the example, where was it? The sample program. Yeah. Here they have mentioned use that infallible type. So that because they want to make sure the response, this async function that we are passing in this server connection, sorry, this service fn is always have an infallible type, result type. So let's go through a simple example. So I have a main function, and I want to make sure that it results and it has infallible. It never returns errors, but it should return result. So that scenario, if someone is writing some program, sub a minus b, q. Okay, let's go through this first. Um, so it's initializing a variable a with 1 and b with 2, and we have an add function, and that function itself we are returning whatever this function is returning, that's what returning from main. So if that is the scenario, or um, you want to define another function, f not error function, function, and okay, how do you pass that function? A box fn. We are passing a function, oh, but it's returning. Uh, so it should be function traits in Rust. Not sure this. Okay, let's see how I just edited this code a little bit. So I have a non-error function. I don't want, or let me call this infallible function. Infallible function, and this also should be changed to infallible function. Okay, so infallible function. I don't know why it is not quick fix. Infallible function here. So this function basically accepts a function, and that function accepts two parameters, and I'm passing that parameters here, a and b. So basically I have an add function here, and I want this add function to be infallible. I know that this never fall, and I want users to pass only infallible function to here. So if someone is again writing uh, an infallible function called subtraction, um, I want to make sure that that function is infallible. So that is through this result unit type. I'm not returning anything here, and it's an infallible. So it's always, I can make sure that this infallible function has always return a result with infallible, never errors. So no one can write an error returning function here and pass it here. So that's why I'm controlling and giving um, users to pass the parameter, a function parameter, which never um, which returns infallible. That means it's never return error. So that's what this infallible. So if I run it, I have run it here. So it's hello world. This is what hello world, and it's calling infallible function and passing this add, and this is what getting called, and here passing function, passed function calling f is actually add, and ab I has passed here. So that's what infallible function. And let's quickly go through advanced error types. So some of the advanced error types are this. I am referring the Rust book, the online Rust book, chapter 190403 here. I don't know it's why it's written 04 here. Um, so yeah, type. So if you want to um, change a type, so if I want to use type, create a type, I want to create kilometers, meters, and I can just assign that to some type I know, I'm aware of. This case I'm giving the primitive type I32. So now you can give kilometers here, a comma kilometers, and if you compile this, yeah, it's still working. We didn't change here, but it's already aliased to I32. So that's what type. So this will be useful when you have some big normally Rust, you might need to handle a lengthy types. So type error equals box or result, results, result equals box or result, in this case result comma infallible. I just want to alias this to result. I don't want to write always. Let's see if this works or not. I'm changing this. Yeah, I'm changing this to type result cycle detected, expanding the alias. uh, uh, my result. I think same name is not allowed. So let's see whether this works or not. And colon, yes, of course I can add. Yes, that's worked. So yeah, now everything is changed to my result, so I don't need to type this everywhere. Instead I can just write my result. That's what the type keyword. Yeah, this is useful when you're dealing with box, dynf and send, static, dash static and all. Yeah, that's what type. I think it's everywhere. Yeah, result t. So they have changed the standard result T stdio error to result T. Okay. Result error is repeated a lot. As such, stdio has this type alias declaration. Because of the declaration, because this declaration is in stdio module, we can use the fully qualified alias, that is a result e with a e filled in as stdio error. So yeah, this way the type alias helps in two ways. It makes code easier to write and it gives us a consistent interface across all stdio. Because it's an alias, it's just another result t comma e, which means we can use any method that works on result t comma e with it, as well as special syntax like question mark operator. Yeah, so in this case, yeah, we just return result usize, just ignore the error part, but error will be returned when you do question mark and all, and it will be standard IO error always. And never type is, if you know one some function never returns, Rust has a special type named exclamation that's non in type theory lingo as an empty type because it has no values. We prefer to call it the never type because it stands in the place of the return type when a function will never return. Yeah. Or yeah, it's not going to return, then you can just type like this, say never return type. It's a diverging function. The never type is useful with panic macro as well. Recall the unwrap function that we call on option t values to produce a value or panic with this definition. Yeah, panic has type never type. Yeah, dynamically sized types. So str is one of the examples. So let's dig into details of dynamically sized type called str, which we have been using throughout the book. That's right, not ampersand str, but str on its own is a DST. We can't know how long the string is until runtime, meaning we can't create a variable of type str, nor can we take an argument type str considering the following code. So yeah, these codes will not work because we don't know the size of this type. So we should always give ampersand str. Rust needs to know how much memory to allocate for any value of a particular type, and always all values of a type must use the same amount of memory. If Rust allow us to write this code, these two str values would need to take up the same amount of space. Yeah, that's not the case, but they are different length. S1 is 12 bytes, S2 is 15. This is why it's not possible to create variable holding dynamically sized type. So that's the reason we are giving ampersand in front of it. It's a pointer, so we know the size of the pointer. Rust knows the size of the string pointer, string slice pointer. Yeah. So that's about that. Yeah, another thing is, yeah, sized. To work with DSTs, Rust provides sized trait to determine whether or not a type size is known at compile time. This trait is automatically implemented for everything whose size is known at compile time. In addition, Rust implicitly adds a bound on size to every generic function. Okay, implicitly adds, okay, size, so it's implicitly adding. So it's when you're writing a function like this with t, it's actually writing like this: t should be sized. Okay, by default generic function will work only on types that has non-size at compile time. Okay, yeah, since it's implicitly writing like this. However, you can use the following special syntax to relax this restriction. So if you want to do some unknown size type also can pass to this, then question mark sized. Yeah, and ampersand t, and you should pass ampersand reference to t. True. A trait bound on question mark sized means t may or may not be sized, or may or may not be sized, and this notation overrides the default that generic type must have a non-size at compile time. Yeah, the question mark trait syntax with this meaning is only available for sized, not any other traits. Oh, okay, yeah, it's only for the size trait, this question mark thing. Yeah, okay, it's only special syntax for size trait. Also note that switch the type of a t parameter from t to ampersand t because the type must not be sized. We need to use it behind some kind of pointer. Type might not be sized. We need to use it behind some kind of pointer. In this case, we have chosen a reference. Yeah, yeah, we cannot pass unsized type here. It's always size, so that's the reason we are passing ampersand t. That makes sense too, but there can be type t which is, for example, we can pass str here. Yeah, okay, and yeah, usually we box it. Yeah, dyn trait, dyn dyn traits are keyword dyn, a dynamic prefix of trait object. Dyn keyword is used to highlight that calls to methods on the associated trait are dynamically dispatched. No, this is not what I want. Um, Not sized types in Rust. Unsized types, yep. Okay, oh, it's the same thing there. Let's see what there is. An example. Sized. Maybe return function. Yeah, for example, fn foo t a t foo plus question mark sized, so it can be unsized, and we are passing the reference. Yeah yeah, the function can be unsized, but we are passing the reference to it. Then this okay, yeah, that could be one of the usage. Yeah, those are the advanced types in Rust. I think that's all I need to cover in this video. So we have covered what is infallible, and this is used in hyper. So we will try to cover this hyper trait in the coming videos. So that time this will be useful. And we also covered some of the advanced types in Rust. Okay, thank you all for watching this video. I think that's all I need to cover in this. Thank you.